is false. That's why the implication is true. Remember the definition, if the hypothesis is false, we do not have to see what the conclusion is. It can either be true, in this case this is true, I should have written like this, okay, and this is false, this is again false. Whatever the case may be, the implication is true, and these two statements are vacuously true. Okay. Now, let me, okay, so far we have only agreed to call vacuously true statements true, but why are they true? We have to understand that. I have not addressed that question till now. Okay, let me try to address that. One way of saying why a vacuously true statement is true is that uh, it is considered to be true as a matter of convention rather than as a matter of fact. See, what does this tell you actually? When X is true, then Y is true. That's what it says. And I mean, we could have done well with that only. Whenever X is true, Y has to be true. If X is true and Y is false, we are considering it to be false. That could have been the definition entirely. There was no need to consider the case where X is false. But this is a convenient consideration. Why, that we will understand soon. Okay, so this is a matter of convention. You can think of it like this. When X is false, this situation itself does not arise in any application. In any application means not just application of mathematics outside of mathematics, but application of implication itself. Okay, if X is false, then the situation does not arise. So, there is no room for it to be false. Or you can think of it like this. If X does not, if the situation X is false, you come across this situation that if the hypothesis is false, then whatever the conclusion is, it does not matter. Although this is not an explanation, I mean, it may very well go over your head and maybe it's not making any sense. Rather, we should go through some examples and some other things which will make it more apparent why we need this. Okay, so that's what we are going to do right now. But before that, let me at least tell you the relationship between implication and if and only if. Implication seems to be one half of this, but in what sense? Let's see. Look at the second statement, equivalence, logical equivalence. By the way, I have forgotten to tell you that there is another name for this situation. It's called a tautology. A tautology is a statement that is always true, and this is not necessarily a double implication. I mean, the law of exclusive middle, that is also a tautology. Any statement that is always true, regardless of the situation, is called a tautology. So the proofs that we did just a few moments ago, those are all tautologies, or the laws of mathematical logic that we have stated, those are tautologies. Okay. Now, what does it say? This is true if either x or y are both true or both false. So in a sense, it says that x and y are equally true. Either they are both true or